Hi everyone, welcome to our video on multiplying matrices in our application problems. Now the main thing when it comes to multiplying matrices with applications is whenever we have a matrix, let's just go ahead and write it up here. Oops, that's a highlighter. So if I have a matrix A times a matrix B, we remember the general method is to make the rows of A multiply the columns of B. So what we need in our application is to make sure the units in the rows of A need to match the units in the columns of B. Okay, and the other rules are still there with matrix multiplication, where if matrix A, let's say, is m by n, B needs to start with n. So these need to be the same also. And then our resulting matrix will be m by k as a final answer. Okay, so, but I think the main thing out of the applications is what we first wrote in the words here. All right, so matrix application, let's read this problem. So it says, fancy bedazzled brand dog collars come in 3 sizes, small, medium, and large. A small is $25, a medium collar is $30, and a large collar is $40. The table below gives the inventory for 3 stores that carry fancy bedazzled dog collars. So we have the 3 stores, and then here's their sizes. Write a product that will give the total dog collar value for each store. Okay, so they want a product, and that's all we will be doing is just writing it. We won't solve everything for it because it takes so long, but we'll get it set up. So it does say write a product, and so what we could do with this is really I just want to take this first and just say, hey, this is a table, but we know where I'm bolding. If I just take that portion, that is a matrix. So first thing I'm going to do, and let's not write it too far to the left. Let's put it kind of right here. And I am just going to fill in those numbers. So 18, 20, 15, 20, 15, 25, 30, 12, 2. And on this same thing, I still am going to mark it. Okay, so small, medium, large. And let's kind of do, I'm going to use just the first letter of these. So this is Pet Plaza, Dog Mart, Lulu's. All right, so we've got our different ones. So I'm just kind of showing how they're organized with their columns and rows. Okay, and we do note that this currently is a 3 by 3 matrix. So that will come into play when we start to multiply. All right, so now that we have the 3 by 3 matrix, let's go back up and see, well, there's some other information. They talked about the small costing $25, medium is $30, large is $40. So we can make a matrix out of this, and this is where we can decide how to create it. Okay, so we've got the information here that we're keeping blue, so I'll just say like the price. We could make a matrix that is horizontal, so 25, 30, and 40. So that's for small, medium, and large. Or we can make it to be where the price is vertical. So 25, 30, and 40. Again, that would be small, medium, and large. Okay, so it's up to us to decide how we want to make that happen. And so it's also up to us on these products to put the correct matrices in order from left to right. Okay, so currently I have a 3 by 3 matrix. Here, with our price matrices, I either have, so this one is 1 row by 3 columns. This price matrix is 3 rows by 1 column. Okay, so that means when I start to set up my matrix, I come back to the rule where the middle numbers need to be the same. So for instance, if I want to set it up with, say I want this to be on the left, well then I need to make sure that this number and this number are the same. And so that looks like it would be this first, or not the first, looks like it'd be the second one. So I'm going to put a star on it. So it looks like it'd be that one to make sure that those are the same. And let's see if it looks like it's going to work. So I've got 25, 30, and 40. So those are where it would multiply. That is a 3 by 1. Okay, so it was 3 rows by 1 column. So that means the answer would be a 3 by 1 answer. Okay, so this would be a 3 by 1 answer. Okay, but the main thing is we just want to get the kind of setup. And then here's where I think, so these letters can help because I can still label these. So this is the small, medium, and large. And what we said in this star portion, let's go ahead and even highlight that star. There we go. Okay, so that star is highlighted now. In that starred portion, we said in matrix products, we need the units for our rows to match the ones of the columns. So that's where I would just say, hey, look at these up here. So that's why it's nice to write them like that. So here's my row units, my small, medium, and large. They match my small, medium, and large right here. So we have a match in the units. So it looks like everything's come together here. Units match. Okay, so that gives us our setup. So the setup without the letters there, they might say, hey, get rid of those for the actual answer. So this here, so I'm just rewriting the numbers without those organization letters, and then times the 25, 30, 40. So this matrix right here would give us a product that gives us the total dog collar value for each store. Okay, so and what that would represent, so when it does multiply, it gives us a 3 row. So whatever those numbers are, it would match our stores right here. So this is the dollar for the Pet Plaza. Dollars for Pet Plaza. That's the dollar amount for the second one. This represents the dollar amount for Lulu's. Okay, so that's what it represents. If afterwards, if we did multiply those numbers and get them, that's what those represent. All right, so that's one way to write this problem out. Now, you might have like a multiple choice scenario where you say, hey, this is the answer, but that answer is not given. So what we need to do instead is figure out how to rewrite our information. And that's where using this first one, so let me go ahead and label it. So that was our 1 and that was our 2. So here we use the second version of it to get our matrix. Well, if I can write it in multiple ways, it means I could have rewritten this matrix in multiple ways. So one more time, let's scroll down. Again, I'm going to write this out. Let's just leave it completely blank for now and show what we're going to do with it and say, hey, this is a 3 by 3 matrix right here. But I know I can't put this second one, or the first, sorry, I don't know why I keep saying 1 and second and first, whatever. So this first one, the 1 by 3, I know I can't put it second in this scenario, so I'm going to erase this because these numbers wouldn't match. Okay, so that's no good. Okay, so let me erase that now. So I know the 1 by 3 would not be able to be second. However, I could put it first. And that way, those numbers are the same. Our answer would be a 1 by 3 answer. Okay, so that's nice to know about. And let's go ahead and write that 1 by 3 right here. So the 1 row and 3 columns, so the 25, 30, and 40. And we can label those as our small, medium, and large. Okay, so this is where we would have a problem. So this is why I left it blank. Let me at least put, if we were to keep it exactly the same, so without putting those in, well then what would be happening, so I have this set up, so that's if it is the same exact numbers. Well, I would be thinking this row, and again, just looking at the units, would multiply this column. Well, here I don't have a match. Again, the previous one, I said the units match, and to really clarify what I mean is the small multiplies the small, the medium multiplies the medium, the large multiplies the large. So that's what's happening here. Whereas this scenario, I have the small multiplying Pet Plaza, so these aren't the same thing. So that means I should change it up. Well, what we can do, So they gave us this matrix from the start. But again, we could have organized it ourselves a different way. So what I'm going to do, instead of leaving it exactly as is, so I'm going to erase those and say, hey, how about we make this the small, medium, and large, and then these could be the Pet Plaza, the Dog Mart, and Lulu's. And then that way, when we multiply, now I've got the rows multiplying the rows. So small multiplies small, medium multiplies medium, large multiplies large. So this is what I mean by having the units match. Okay, and then we already know that we can multiply. So we have it set up in the correct order. And so that just means I need to rearrange these numbers. Okay, so what we've got is, so the 18, 20, and 15, that was the first horizontal row. Well, all I'm doing is making it vertical. So write that 18, 20, 15 downward like that. So we're kind of rotating the numbers around. Okay, so the Dog Mart, which was the middle row, I want it to be the middle column now. So 20, 15, and 25 downward like that. And then this last row, 30, 12, and 2, well, I need that to be vertical. And then now everything's a match. So notice how the numbers got moved around in this big matrix. And that's to make everything multiply out. And I'm just boxing this, but we would probably get rid of the letters to show the final product. Okay, so that's how we can break down these applications. If you want to, you can pause. I'm gonna keep this on the same video though. So let's get one other application problem in here. This time around, they gave us multiple tables though. So I think this is actually a little nicer to show what we've got. So in this example, it says the 3 departments of Granges Incorporated need to order the following amounts of products. Okay, so there's the departments and then there's the products. The unit price in dollars of each product is given below for the 2 distributors. Okay, so these are dollar amounts, and so we've got our products and we've got the distributors. Okay, number 1, use matrix multiplication to get a matrix showing the comparative cost for each department for the products from the 2 distributors. Okay, so currently, what we want to do is kind of what we did on the previous problem, where I could say, hey, this is a matrix, so I'm just kind of blocking off what's important about it, and making sure the units would match. All right, so currently what we have is 3 rows and 4 columns for this matrix. So this is a 3 by 4. This matrix is a 4 by 2. So 4 by 2. Okay, so it looks like the order that we would need this in, we need the 3 by 4 to multiply with the 4 by 2, because then those two numbers would match. So this should be the first matrix, and this should be the second matrix, and then hopefully all of the units are going to match just fine. Okay, so notice again the order is important here with our matrices. So this 4 by 2 could not be first. 4 by 2 times in a 3 by 4, because then our dimensions would be no good. Okay, so the order there is automatically kind of set. All right, so that means let's go ahead and set it up with the 3 by 4. So I've got 8, 5, 3, 20, 10, 12, 2, 16, 21, 16, 7, 31. So there's that. And then let's mark what they have in common in each table. So notice they got, let's highlight these and these. Well, I think this one's going to be set up real nice for us without having to worry too much about it. So this is our pencils, markers, calculators, and notebooks. Well, if I write this one as is, so the 50, 45, 60, 55, 100, 120, 50, and 60, going the vertical way, this is the pencils, markers, calculators, and notebooks. So, and when we do our row times our column, it is an exact match. So the pencils multiply the pencils, the markers multiply the markers, the calculators multiply the calculators, and then the notebooks multiply the notebooks. Okay, so this is the units match. Okay, and then we already know that it will multiply. Okay, so we talked about that up here. This is a 3 by 4. This is a 4 by 2. Okay, so we have a 3 by 4 times a 4 by 2. So these are the same. I just wanted to write this to show 3 by 2 would be the size of the final answer. Okay, so step 1, we use matrix multiplication to get a matrix showing the comparative cost for each department for the products from the two distributors. Okay, so this is showing how we would multiply it. Okay, and then number 2, it does say find the total cost over all departments to buy products from each distributor. From which distributor should the company make the purchase? All right, so that's where they want us to actually multiply those matrix out. Well, I think this is a good one for a calculator. Okay, so let me scroll over. So I'm going to use Desmos. Okay, and let's go to Math Tools and Matrix Calculator. And then let's just get those matrices in. So new matrix, it's got 3 rows, 4 columns, and then 8, 5, 3, 20, 10, 12, 2, 16, 21, 16, 7, 31. And then double check all those numbers. I think they are good, so I'll press enter on that. So you can't see everything, but there's enter. And then let's make our second matrix. Okay, so new matrix. This has 4 rows and 2 columns. So we have 50, 45, 60, 55, 100, 120, 50, 60. And then there it is, and we press enter. Okay, and then this is where matrix multiplication is nice. So I am doing matrix A times matrix B, and then that's it. There it is, enter. Okay, so that saved us a lot of scratch work. Now, in the videos before where I was doing it by hand, I mentioned you could set it up in a calculator. So if you never were able to get it, I hope this helps. But we were able to skip a lot of steps. And then now we have this, but we need to make sure we can interpret that answer. Okay, so I'm just moving it to the side so I can rewrite it. Okay, so let's say, I'm just going to say like this, A times B. Okay, where this was, okay, so I'm going to get a little messy. So this was matrix A, this was matrix B, and that's what we did. And we got 2,000, 2,195, 2,220, 2,310, 4,260, and 4,525. Okay, so this is the matrix. Now, actually, let me read this number 1. This might be the final answer that they actually wanted for number 1. I was mostly concerned with setting it up. Okay, so use matrix multiplication to get a matrix showing the comparative cost for each department for the products from the 2 distributors. Okay, so this is probably the final answer for number 1, not just the setup. And then from here, we're going to take it and answer number 2. So this right here, I'm going to say number 1. That is our final answer. Okay, so I got distracted. I was focused on just the setup. Here is the final answer for number 1, though. Okay, and what we want to do with this is, again, we want to make sure we know what this stands for. So what we did is, when we had the rows, we multiplied these columns. Now, I didn't mark the other stuff that was involved in those matrices in that first step, but this was like the department 1, this was department 2, this was department 3. And then these were the different distributors, distributor for A, and then this is the distributor for B. Okay, well, these in the purple are still pretty much here. Okay, so this is still distributor, let me mark it. So this is distributor A, this is the distributor B stuff, and then this is for each department. So this is, right, and then these are those costs. So what we were doing was multiplying some dollar amounts by a quantity. So this is the department, let's say department 1 cost is these here from each distributor. From each distributor. This row is the department 2 cost from each distributor. And then this last row is the Department 3 cost from each distributor. Okay, so what they want us to do in this to figure out this answer is they said find the total cost over all departments. So that means they want us to add all of these department costs together by the distributor. Okay, so that means let's just add those together. So we would have 0, 8, 4, and then 8. Okay, so this dollar amount so that's the dollar amount using so this is the dollar amount for all departments added up. So this is the sum of all departments based on distributor A. Okay, so that's what that one is. And then let's do the same thing with this other one. Let's add those up. So if we add those up, I think 5 and 5 is 10, and then this becomes 13, 1, and that's another 0, and then that gives us a 9. So I'm doing that mentally. I should maybe double check it. So 0, 10, 12, 13. I think it's good. Okay, so we've got, so if I did make a mistake, you can let me know. Okay, so but I think that is correct there. So that dollar amount, so that's the sum of all departments based on if they use distributor B. Okay, so now we can answer their final question. So from which distributor should the company make the purchase? Well, if they want to keep cost lower, they should use distributor A. Okay, so distributor A has lower cost. So that's how that should be broken down. So that's how the matrix application could work. So it's trying to organize all the data still in a table, and then even from there we could break apart what's important to our matrix table and find an answer to whatever they are asking for. Okay, so the main thing though I think is getting the setup. So my biggest suggestion there is just write in those little letters, make sure those units match if you were to do the row times the columns. Okay, other than that, that's it. So matrix stuff, I'm done with. So we're done except for your stuff on test or whatever. Okay, so if you do have questions on it, please let me know. Otherwise, thanks for watching, and I'll see you again soon.